Hello, my friend. My name is Anton from Canyon.com, and today we are glad to introduce you a new product that we have recently created. I hope you enjoy our gNMI library, Python open source library to manage networking devices with gNMI. And today we'll show you the new product which is based on that library. So for those of you who are using Python daily, obviously, if you need to manage your devices in a model-driven way, which is the only way to manage devices these days on a scalable way, and therefore this is the future, you know that you can create any complex script with gNMI and create it also for configuration devices, retrieving the data and the telemetry connection. But if you need to do it at scale, you need either to introduce some more complicated scenarios like leveraging on the string pool executor or other Python techniques, or you could rely on some frameworks which will do this trading for yourself. One of such frameworks is Nornir. This is very popular framework these days for all sort of network automation due to its scalability and stability, and it has a possibility to give you simplicity into managing multiple networking devices. By multiple networking devices, we talk about like tens, probably potentially hundreds of the devices as well. So it was possible to previously use gNMI as well with an Nornir, but it would require you to create on your own tasks, which was relatively easy, but still requires some good understanding of the Nornir. We decided to simplify that part and to create functionality, basically a new library, which is called Nornir-PyGNMI, which will help you to manage network devices. So let's take a look how the things is working so that you can get up to speed. So Nornir and PyGNMI working together in the same way. The first of all, the library, which is called Nornir-PyGNMI, is based on PyGNMI, and whenever it will be installing, it will be downloading that one. We created it with the focus on the latest Nornir, so 3. something version. We didn't test any compatibility with the previous versions of Nornir. It may work, may not, don't know, but definitely have tested it for all versions of the Nornir from 3. And onwards. The main purpose of the library is to simplify the management of the devices. If you have Nornir, or if you plan to use Nornir for your automation and your networking device support gNMI, I think these days this is the best way going forward, is to rely on gNMI, and Nornir-PyGNMI is helping you to do that. We have implemented the 3 capabilities, or 3 RPCs, which is the capabilities, the request which allows you to retrieve the set of support YAN models from the networking devices GET, the request which allows you to retrieve any configurational data, and also set which allows you to push their configuration toward the networking devices. We haven't so far implemented subscribe request, which is we're still evaluating whether it would make sense to do or no, for the simple reason because generally Nornir is not the tool to create the subscribe any sort of the like long-running subscriptions, but there are certain use cases we have recently encountered that could help to work with that one. So you see here the link to the documentation, so which is quite detailed. It contains the explanation how you could use this library as well. It contains the examples directory, which has quite a bit of documentation, including the details how to structure a project, which parameters needs to be provided. We'll go through that or in this demo as well, but you would use this GitHub repo as main reference. By the way, if you like Nornir-PyGNMI, don't forget to start the repo to give us some more motivation to develop further functionalities. So going back, we have covered what we have supported, or we have created so far in the Nornir-PyGNMI. Let's take a look into the example of the code. So I said we support gNMI capabilities, get and set RPCs. They are created as tasks. And to add them to your script, you just install the Nornir-PyGNMI library as you install any other library, as you install Nornir itself. Then you import from the Nornir-PyGNMI tasks model, you import gNMI capabilities, gNMI get, and gNMI set, which are Nornir tasks. So the way how you run it is simply when you run your task, you provide the name of the predefined task. For the task, it requires certain parameters like get, set. You would provide these parameters after the comma, after the name of the task. So this is a standard way of passing parameters to, let's say, parameterized task in Nornir. And this path will show you in a few moments. These parameters are exactly the same, and you would have NPyGNMI library if you use it without the Nornir itself. So let's take a look. Obviously, as you see here, we just importing config file. Obviously, in config file, we'll have some link to the repository, to the inventory, but as we work with the devices, and if you work with previously with Nornir, you know that you would need to specify some connectivity parameters. So how to specify PyGNMI capabilities so that you use PyGNMI to connect to the devices, and how to specify other parameters. So this is where Nornir inventory comes to a stage. So within the Nornir inventory, we specify the host name and the port, which would be then translated, if we create the same equivalent with the PyGNMI itself, into the target parameters, which is the tuple containing both IP address or FQDN. IP address could be both IPv4 and IPv6, and the port number. Then you have possibility to specify username and password. Again, these parameters, so username and password, would be copied to the corresponding parameters within the gNMI client class when you're creating the object. Then, so this 4 parameters, host name, port, username, and password, are mandatory when we work with PyGNMI. They're mandatory because there are no default parameters for port. I mean, obviously, username, password, and host name, they are unique. You need to provide them in any case, but you need also to provide the port in case of the gNMI, because different vendors run gNMI on different ports. For example, Nokia and Cisco SXR run with the port 57400. It's configurable. You can change it, but this is a default one. So by default, Arista is running on the port 6030. By default, Cisco Nexus run on the port 50051. That's why there is no any default in the PyGNMI library, because there is no any default in the gNMI standard as such. So specify these 4 parameters. If you need to provide any extra parameters, which you normally would specify within extra parameters within the gNMI class, you do it within the connection options. You specify that your connection type is PyGNMI, and as extras, PyGNMI, you provide everything that you would typically provide to the class father. If it is insecure, you just specify insecure true. If it is skip verify and you would like to provide a specific path to the certificate, you do that in the same way. So technically, you could think about in the PyGNMI, in the connection options, PyGNMI extras, we provide everything that you provide besides target and username and password within the gNMI class. For example, if you have the authentication, these tokens will go into the extras as well, or if you would like to specify, set skip verify or override or any further information. So therefore, the information out of inventory helps you to construct the object itself. So when the object is created, connection to the specific host is established, you need to run certain tasks. And this is where the pre-created task is gNMI capabilities, gNMI get, and gNMI set are coming into the game. So again, the way how it is working, if they originally the corresponding method from PyGNMI doesn't require any parameters like capabilities, for example, you don't need to specify anything besides the name of the task. So you run is like nornir.run task. You provide the name of the task that we have created for you in the Nornir-PyGNMI library, and it like example in or equivalent PyGNMI would be running the capabilities call without any parameters. Where the request is parameterized, for example, get. For the get, you need at least to provide the path with at least one value within that list. So the way how it is working, in the Nornir, after the name of the task, you would put comma, and after the comma, you have a possibility to provide the parameters. And these parameters would be the parameters that you would typically pass towards the get method within the PyGNMI library. So you could specify pass, you could specify data type, encoding, prefix, target, and other things. Whatever you need to specify, you just provide into the task, and you could think about this will be translated into the, if you work without Nornir, into get with all the parameters that you have passed. So the same is applicable to the set you will see in the demo, and this basically the way how the library is working. So we try to, on the one hand, to simplify usage as much as possible, on the one hand, to rely and to make sure that if you're already familiar with Nornir, we have the same experience as you would have with using, for example, some legacy automation types like as a netmico or like a Scraply netconf or just general Scraply, but obviously relying on PyGNMI. So let's take a look on our Deva topology, which will be right now guiding you through. We have a server which is running the Nornir-PyGNMI. It doesn't run it yet, but we will install it right now. So you'll see how to start from scratches. And we have 3 networking devices running different operating systems. It's Nokia SRS, it is Cisco and XOS, and there is the EOS. So Nokia is running in insecure mode, Cisco and Arista running in the secure mode. So both of them have self-signed certificate, which will require us to specify some extra parameters to deal with self-signed certificate. And the Nokia is running in secure mode, again, to give us possibility to show you various connectivity types. So let's jump now to our host. And first of all, let's create the virtual environment where we would be running our test. So we'll create it as Python 3.9 in my case, creating the virtual environment. It will take a moment or two for virtual environment to be created. Once it is created, we are activating it, and we would create a file with our requirements, which in our case, we would have only 2. This is Nornir-PyGNMI, our library, as well as the Nornir utils to import the print results function to be able to easily to work with the result. So let's do that. So we'll add here Nornir-PyGNMI and Nornir, I believe it's called utils. Now we would install this libraries, PAP install. First of all, let's upgrade PAP itself. So to make sure that we have the latest version of the PAP. And then we install these models. So as you see, a bunch of the models installed as usual as a dependencies we deal with the Python, because Nornir-PyGNMI relies both on Nornir and PyGNMI. You don't need to install Nornir separately. Nornir-PyGNMI will download and install it for you. There is no some sort of, like customized version of Nornir, just Nornir is a dependency for Nornir-PyGNMI library. As well as PyGNMI, by default, it installs the latest version of PyGNMI available, likewise the latest version of Nornir. So once we have our models installed, we could just quickly check what we have so far running. We see the long list of models. But we could find that we have PyGNMI version 0.85, which is, to the date of recording of the video, the latest one. We have also Nornir 3.3, and we have the PyGNMI, Nornir-PyGNMI, which is, again, the latest version, and Nornir utils. So now we could start creating our library or our application to deal with networking devices. Let's quickly check that all of the networking devices are reachable per our topology. So that is working now, it is because it's running the address for sure. So Nokia is responding, Arista is responding, and Cisco is responding. So all 3 networking functions are reachable. Great. Now let's create a few files. We'll create, first of all, the config file. So the config would have a very simple structure, the same as we have in our documentation, which I shown to you beforehand. So you could see that config file is provided here, and generally our demo follows the same structure as it provided in the same file. Then the important part here is just the host files, which we'll be using as an input file inventory. We have logs where we'll be storing, and we're using the default threaded model with 20 workers. So obviously, if you're not familiar with Nornir, but you have heard a lot of the things and want to use, we have a training, network automation with Nornir, where we are talking not only about PyGNMI, obviously PyGNMI is an important part, but we also talk about Scraply, we talk about the Paramico, SCP, and other models. So if you want to learn network automation with Nornir, take a look into our training. You will have a link to the training in the description, so that you can get up to speed with this wonderful framework, and obviously to learn from us, the authors of the Nornir PyGNMI. Then, once we have created our config file, we need to make sure we create this inventory file. So what we do, we create inventory directory, and within the inventory directory, we'll create the file hosts YAML. So hosts YAML is created. Let's fill it in with the information per our topology. So as said, we have here a number of networking devices. Let's take a look back. So we have Nokia SRS with this IP address. We have Cisco Nexus, and we have Arista. So each of them is running on, for each of them, the gNMI is working on a different port. So all of them are already pre-configured to work with the gNMI. So we wouldn't be touching the devices directly. We'll do it through the gNMI already. So again, as provided in the documentation, so you could see that how their file would be looking like. Standard inventory per Nornir format. We need to specify the name of the host, which would be like our dictionary. In the dictionary contain the value with dictionary itself. So host name, port, provide username and password here as well, and connection options for PyGNMI. Everything, as explained before, that you would provide extra to the gNMI client class when you're creating the connectivity to the device. So let's copy that. Obviously, we'll amend it slightly in terms of the host name. Let's probably call it simply Cisco NXOS. So in our case, this is device 18. So we'll need to create the certificate, which we will do in a moment. In fact, certificate already created, we just need to copy it. This is a functionality about the gNMI itself. And the way how the gRPC server is creating the devices. For some networking devices, such as, for example, Arista EOS, it's possible to download certificate automatically without need to store it locally. For other devices, it is not support, like for Cisco Nexus or Nokia SRS router. You need to download certificate up front in order you could establish the secure connectivity. So let's call the device the certificate also Cisco NXOS.pem. We'll copy that from the device in a moment. And let's create the connectivity for a few other devices that we have. Let's call it next one, Arista EOS. We would specify it as the same device, but we'll call it so sorting the host name, and the port is 6030. For the Arista, as said, we are able to download certificate directly from the device, so we don't need to store it, which is great. And for Nokia, again, as explained a little bit earlier, we wouldn't use certificates at all. We'll create insecure timer just to show you that different options here possible as well. We need to provide the corresponding port. We need to provide the corresponding IP address, as well as we will change, obviously, the name, the host name of the device, so that we have it. So we have created the inventory to work with the network devices with the Nornir-PyGNMI. Now we need to create the file with certificate for Cisco Nexus. So how we do this? We just create the new folder, call it cert. Before actually creating the certificate, we'll add here the username for all devices. So username would be for Cisco, we're using admin. For Arista, we're using the ZTH-NAT. So this is devices we're using in our zero to hero network automation training. If you'd like to learn more about network automation, not only Nornir, but in general model-driven things, OpenConfig, netconf, Ansible, Python, come to our zero to hero network automation training. Very big one, about 55 hours of videos and 1 hour of labs. But if you do the training, you'll really become the network automation expert true network automation expert. So and the same we'll use for Nokia. We wouldn't specify here the password. We'll just ask the password at the moment when we are running our script. Now let's create the certificate that will be called Cisco PEM. So the file. So where we get the certificate for Cisco, we need to go to the Cisco itself. So we'll copy this certificate that we already created on the networking device. Good. So that is ready, and we are ready to create our script with PyGNMI. So let's start it with that. So we'll create, we'll also create the logs directory, which we'll be using for storing log from the Nornir, and then we'll finally create our main.py script. So as said, we technically need only a few libraries to be able to start with. So okay, let's install our linter so that wouldn't annoy us later that we don't have the linter installed. Once this is done, let's create first modules. We need to import just a tiny amount of model. First of all, we need from Nornir, we need to import an object, which is the main class, which is creating, or a function actually, which is creating the object for us with an Nornir. Then we'll need to have the library that we will be using for printing the results. And the core of this topic, for our gNMI tasks, we need to import all type of the tasks. We start with the gNMI capabilities, and then we'll gradually be adding other elements. So let's create some variables. So config file for Nornir is provided within the path config.yaml. So, and finally, we start creating our body. So creating the Nornir object, it will be interacting. So config file. Once we have created this file, we need also to import one more library. So from getPath, to import the getPath function to provide secure password. Then we'll ask, or we will basically ask the password at the moment when you launch the script. So our default inventory default password will be equal to getPath. Right password. for devices. And then once this is done, we finally calling the task where our task run, where the task name would be the name of our function gNMI capabilities. And let's print the result. Print result equal result 1. All right, so our basic function is ready. So we see we have used everything that we need. And we're creating the Nornir object. We're providing the password, so to augment what we already have in our inventory. And then we are running the task with the gNMI capability. So let's do this. So let's run it as a Python main.py. All goes well. We should see right now the request for the password. So let's provide it. All right, so we see that we get few answers, namely we get the response from Arista, which is great. So we have username and password, the four matched. For just jumping back to the inventory, so you see we have for Arista specified password, and then I didn't specify the certificate, but we specified it should be skip verify. That's why you see here the messages that we are skip and verify that part, and you see the response in the nice format. So it's already Python dictionary. So we see also the response for Cisco Nexus. So it is here, and for Nokia, something didn't work particularly right. And let me take a look if I did any typo in any of our configurations. Okay, so looking, where did I make any mistake? So the mistake is that I have called previously username as a proper username, as it is supposed to be called in the Nornir, and here just called the user. Obviously, this is a completely different variable, and therefore it's simply not working. Now we can rerun our script, providing the responses, and we see now we get the response from the Nokia as well. So you see that parameters that we have in the host file for our tool has worked correspondingly, and it worked fine. So our Nornir script has also worked quite fine. Now, the next step for us would be to say, okay, capabilities is working great, simultaneously working for multiple devices. What else we can do? As said, get and set is supported as well, and I'm going to show you them. Now, I need to make the here important point. The Nokia and Arista, they support OpenConfig. Cisco Nexus also supports OpenConfig, but not in the virtual versions that we are using. So Nexus 9000V doesn't support it by default. So therefore, we wouldn't be able to run it, and you will see we'll be getting the errors. However, we'll show you get from both of the devices. You could think about why basically OpenConfig is a great thing. But also you could think about that you could probably, again, create the task on top of our standard gNMI get and set to add some augmentation. But this is a quite complicated topic. We'll leave it to you for self-experiment, or if you'd like to learn more about Nornir, as I said, join our network automation with Nornir training that is available in self-paced mode. So, and here gNMI get, let's collect some data from the devices. So NRN run, our task would be gNMI get. Now we need to provide the parameters. The parameters are generally the same as in our library in the PyGNMI itself, as explained before. So you could take a look on the documentation about the PyGNMI. There is a simple way. You could just, if you have gNMI, if you have VS Code installed, just with a control, click on the library, and it's open for you the model and give you details what actually could provide. So you see prefix, pass, target, data type, and so on. So I said exactly the same parameters as we have in PyGNMI itself. And you see actually under the hood is PyGNMI itself, just in a simpler way. So, all right, now what we will do, we have provide here the pass for example, open config interfaces. And let's print our results. Sorry, print result. We could provide this as a name key. We could provide as not a name key. It will work equally like here or like here in the same way. So now I don't really need to print the capabilities. Probably will just hide this for a moment. And let's run the Python main. Providing the parameters. Did I make some mistakes? Probably I did. Should probably start experimenting. So, so let me do that. Let me copy the keys that I need to use for this pass. All right, so now right, so now everything worked fine. I didn't make any typo, and we see the responses here. Now we have an error. We'll get to the error in a moment. So first of all, you see you have collected in the nice Python dictionary format the content of this XPath. So the XPath was open config interfaces. So in the open config models, which we are covering extensively on the derivative here network automation training, you would see the vendor independent way of the basic parameters such as interface counters, IP addresses, if it is obviously supported by the networking device. Supported by the Nokia SRS, supported by Cisco SXR, supported by the Arista OS, supported by the Nexus in the like hardware devices in some latest versions, and supported in some other vendors. But in our case, it's not supported by the Nexus, and you are getting the error. Let me see it. So basically, the error is structured in the normal Nornir way, and you see that there's so enable to resolve model for passings, provided that this path that we have provided is not known, which is fair if the YAN model is not supported by the device. And you also see the response from the Nokia. Nokia is supporting this as well. So all good with Nokia in the open config provides us the configuration of the devices per the device, how it is done right now. Good. So get is working. Let me quickly show it to you to our Cisco NXOS. So we provided the path which is supported by Cisco NX. Obviously, it would fail right now for Arista and Nokia. But you will see that the get is working on the devices, on those devices as well. So you see one big response from Cisco Nexus. So very, very, very long because there's a lot of data there. And errors for two other vendors. So yeah, because the element is unknown. Again, so the structure, how the errors are handled, we for the Nornir-PyGNMI created the same structures working for the Nornir as well. So the errors which arise, they are passed to the task, and then you could see what exactly is the problem. Okay, clear enough. The PyGNMI exception that telling you that system is slash system is a known element, so it's known part of the XPath. So from now on, just to move a little bit quicker, we will just focus on a single vendor, because despite open config is supported by the Arista and by Nokia, the reality is that they have slightly different naming conventions from different elements. And what I want to do is I want to show you how set task would be working. So I will simply comment out everything besides, for example, Nokia for the time being, just to simplify our track. So we'll get here the OpenConfig interfaces. Now we'll add 2 more tasks. We'll add gNMI set. So get before and after change would be the same, so we will retain the same task. What will be different here is that we will be using set model. As we will be using set, obviously set require different parameters, and the way how it is implemented in PyGNMI, you would need to provide the list of changes, and the list contains tuples with XPasses and the parameters you would like to pass to the XPass. So let me create such type of list so that you would see how this pass would be created for Nokia. So I said so this is following OpenConfig models. OpenConfig models, I said before, is extensively carried in zero to hero network automation training from us. Join to learn more about the Yannick models in general, how it is working. So creating the loopback interface, this is the XPass towards which we interface are going to create, and this would be the parameters that we are passing for this interface at the moment of its creation. So now I'll run my, I'll pass these parameters. So this update message, again, how I know that's update, Control, click on the gNMI set and opens the documentation show that you need to provide delete, replace, update, encoding. So all these parameters that you could find in gNMI library itself, on which we're actually building the Nornir-PyGNMI. So adding this information and pushing the configuration toward the device now. So let's push it. So we see the change is almost instantaneous. The speed is one of the biggest advantage of PyGNMI on top of any CLI configuration, on top of netconf. Now let's see. This is the list of the interfaces in the OpenConfig interfaces YAN model. We see that we have interface name system type software loopback. So if we'll scroll a little bit down, we'll see another interface 111C1, which is Ethernet. Great. So then we will have another interface 11C21 interface Ethernet. Then we see that change has happened. So we're following the Nornir functionality on the signaling the change, whether it happened or not. So we see the change has happened. And then we see the collection of the data again. We see system interface, we see new interface loopback, which was not existing before. Now, as its dictionary, which is PyGNMI gives you, you can build any, using DeepDiff or any other library, comparison of the created element just to validate that your change is exactly has happened. So you see, we have it create, we have description, we have type of the interface. So all others types of the requests, so update, replace, and delete, that would working as well. So let me show you delete, how it is working. So say I would like to delete this configuration, because replace would be working exactly in the same time. So exactly in the same way. Or let me probably show you replace as well. So I will create the replace message, which would look like as this. So we're providing the key and we're providing the value which we'd like to amend. We could use update for that as well, but we could use replace either. So then I'll call here another RPC. So it's not the matter how I call the variable. I could call it all the time the same. Just matter which RPC I'm calling internally within the PyGNMI, within the gNMI via PyGNMI library. Update, replace, or delete. So let's run as replace. And for the collection of the information, we can basically request explicitly data from that pass, so that we just focus solely on this bit. Now I'm running my script. We could see that our description was created with love by Nornir-PyGNMI. Text successfully executed the change. So we see that it was changed. And now we see the new value replaced with love. So basically the new value is set. So that is how you do it if you like to replace. You could replace a bigger context, not only in single key value pair. And I said, you can update it. So the difference between the replace and update are extensively explained in our Zero to Hero network automation training. As usual, subscribe to learn more about model-driven automation. And finally, we use a delete, which is a simple list of elements. We would simply delete this key. And we'll be tracking again all the interfaces, not only the loopback, because we need to see what is going on. And rerunning our script again. So we could see that we have this interface loopback beforehand. So it was right after system and before the physical interface 11C1. Now we look after the change and we see that it is software loopback and then it's gone. Obviously, we have seen right now how in general gNMI is working and the benefit of model-driven automation compared to any text-based based on the network and so on. Because the model-driven automation is already today's and the future of automation. So, and with this video, I hope you have a quick intro into how Nornir-PyGNMI is working. As said, if your network device support gNMI, I think from all existing protocol these days, this is the most advanced and the quickest way of doing the changes, because it's also support not only configuration management, but also streaming telemetry. So with the help of PyGNMI in general, management of networking devices via gNMI is very simple. And if you're using the Nornir or planning to use a Nornir, you see that your hopefully favorite gNMI library is available and will help you with this automation as well. Thank you very much for watching this, for watching this video. I hope that you liked it and learned a lot of new things for yourself about how gNMI is working, Nornir-PY and gNMI. We would be happy to share our network automation training as a Zero to Hero, where you can learn a lot of model-driven, open config, gNMI, netconf, and all other things and tools in total, or Nornir, where we're doing the deep dive in this library. Thank you very much for watching and see you again. Thank you. Goodbye.